Hello everybody! I will present a gravitational model in 3 dimensions which exhibits Schrödinger connection with self-dual nometricity vector. In this model, the inhomogeneous Maxwell equations will emerge from a purely geometric setup. Let me start with a brief introduction on connections and in particular on Schrödinger connection. In 1918, Weil attempts to unify electromagnetism with gravity geometrically, and to do so he introduced a new connection involving nometricity, and he tried to associate the trace part of this nometricity, that is the Weil vector, with the gauge potential. But the theory had physical inconsistency, in particular it exhibits a second clock effect. Subsequently, Schrödinger introduced a new connection that involves nometricity, but it's particular since it preserves the length of vector under parallel transport, and so is more physical than Weil's one. The connection introduced by Schrödinger is symmetric and can be written in the following way. We have the Levi-Civita part and a tensor Z that is symmetric, but its completely symmetric part is 0. Now we can consider a generic affine connection written in terms of the Levi-Civita part plus n that is a tensor written in terms of nometricity and torsion. And one can then prove that setting the torsion to 0 and the completely symmetric part of n to 0, we end up with a connection where the nometricity can be identified with a Z of Schrödinger connection. Therefore, we end up with the form of the Schrödinger connection written in terms of nometricity. Now, since we are going to introduce a model in 2+1 dimensions, let me give you the decomposition of the nometricity tensor in 3 dimensions. We have that Q lambda and Q tilde lambda are nometricity vectors, traces, while omega is traceless. I can now present our model in 3 dimensions, in which we have an FR gravity terms, where R is the scalar curvature, and a Chern-Simons term for the nometricity, where we have also introduced the homothetic curvature tensor. And we also introduced a Lagrange multiplier for the torsion. Epsilon mu nu rho in the action is the Levi-Civita symbol. Variation of the action with respect to Z gives vanishing torsion, and variation with respect to the metric tensor gives us the metric field equations, and we have a particular solution for which the scalar curvature is constant. And we get the metric field equations, which would be Einstein-Weil equations in the case of Weil nometricity, but this is not the case in this theory. From the variation with respect to the connection, to the general affine connection, we get these equations, where P is the Palatini tensor written in terms of nometricity. And from these equations, we get that the traces part of nometricity is 0, the Lagrange multiplier is expressed in terms of the homothetic curvature, and the latter is expressed in terms of the nometricity traces. We also get this equation for the derivative of f prime, and finally we end up with this form for the connection written in terms of nometricity traces. Then, in particular, considering the constraints on f of r arising from the metric field equations, we get a generalized monopole equation, and also a condition on the derivative of the logarithm of the scalar curvature in terms of the nometricity traces. Now, if we take a sigma in the generalized monopole equation as a constant, we get this relation, which is self-duality in 3 dimensions. And in this particular case, we have that Q tilde can be written in terms of Q in this way. But setting sigma constant is equivalent to choosing the solutions with scalar curvature constant. Hence, we focus on this particular case. We get some relations, among which an equation relating the homothetic curvature with Q, with the nometricity trace, independent nometricity trace. This can be dualized in this way and implies this gauge on Q. In particular, we have that the completely symmetric part of the non-metricity, in this case, is equal to 0, and therefore we can write the final form of non-metricity and of the connection, which results to be the Schrödinger connection, but with a self-dual non-metricity trace Q. This self-duality is a self-duality in odd dimensions, and we will see now how it is related to the inhomogeneous Maxwell equations. Self-duality in odd dimensions was considered by Tausenpilch and van Nieuwenhuizen, who considered the square root of a Proca equation for a massive antisymmetric tensor field, and they show that this leads to a self-dual field. In our model, we have self-duality in 3 dimensions. We have this relation that is the self-duality 1, where F is nothing but the homothetic curvature, and M is mass, which is written in terms of the Chern-Simons coupling constant. We can write it into the dual form, which implies this gauge, and the covariant Proca equations, which can be written in this way, and also into this other way in terms of the ordinary derivative. Then Q can be interpreted as a massive photon gauge field, but the covariant Proca equation is equivalent to inhomogeneous electromagnetic wave equation following from inhomogeneous Maxwell equations, and therefore Q can be interpreted as massless and source of itself. To see this explicitly, we consider our wave equation of our model, that is this one, and the inhomogeneous electromagnetic wave equation for Q mu in the gauge nabla tilde Q mu equals 0, that is this one, where mu 0 is the vacuum permeability and J mu is the current, the source current. Then, using the self-duality relation in our model and our wave equation, we can see that we precisely obtain the inhomogeneous electromagnetic wave equations also in our model. And we can write it in terms of the current and define the source current in this way, and finally write it in terms of the non-metricity trace. One can then prove that the source current that we have just defined in terms of the non-metricity trace is covariantly conserved. This means that we cannot define globally conserved charge, since we need a local conservation law for doing this. But then we can use our Proca equation, which is this one, and define a total current given by the source current plus the self current, which is indeed locally conserved. We can conclude by saying that our Proca equation is an equation for a massive photon, but can be interpreted as the inhomogeneous Maxwell equations with corresponding wave equation, and the photon can be seen as a source of itself due to the self-duality relation. And in this framework, gauge invariance of the connection and of the inhomogeneous Maxwell equations follows from self-duality. Then we can call this vector, this non-metricity vector photon, and in our framework we can at the end conclude that the inhomogeneous Maxwell equations emerge precisely from a purely gravitational setup. We can also observe that projective invariance is broken in our model, therefore consistent matter couplings are allowed. Regarding the dynamical degrees of freedom, we have just one dynamical degree of freedom for the non-metricity trace. Gravity in 3 dimensions is not dynamical. This is obviously a toy model. It would be very interesting to extend it to higher dimensions. Thank you for your attention.